Okay, once again, good afternoon, and we are now into the third session of today's conference. And incidentally, Joydeep, Dadar TT was the full name was Dadar Tram Terminus. That is why.
That's correct, sir.
Tram
Dadar
Terminus.
Yes. Yeah.
Okay. Wow. That's
So,
the information.
Yeah. So the third session is by Mr. Jitendra Sondhi, who is a World Bank consultant. And the subject again is fitting with the conference theme today. That is the development of high-speed railways in China. And the moderator for today is Mr. Ranjit Virdi, who is a mechanical engineer, a career railwayman, and has served in Indian Railways in various capacities from 1973 to 2015. His last posting was as general manager of the Northeast Frontier Railway. And if you remember Dr. Debroy telling about the Northeast Frontier Railway, many of the places would have been visited by Mr. Virdi as general manager also. And post-retirement, he settled in Delhi. And of course, he's also a life member of the Rail Enthusiast Society. Over to you, Mr. Virdi.
Thank you, Mr. Pandey. I'm sure everybody can hear me.
Yes, sir. Here is a NFR railway child. I'm NFR railway child.
It is my pleasant duty as the moderator to welcome all the participants to this session of 1 hour for the global conference on the future of the railways of the future. And to introduce the speaker for this session, Mr. Jitendra Sondhi. He is a railway engineer and management consultant. He did about 20 years with the Indian Railways and then moved over as a consultant and did various consultancy projects for the World Bank and other multilateral lending agencies. In the course of his career as a consultant, he has visited over 20 countries, evaluating railway projects in those countries. And his talk today is on development of high-speed railways in China in the period 2008 to 2021. In this presentation, he has drawn on his experience in covering evaluation of railway projects in China over the period from 2000 to 2018, which is an 18-year period in which he covered 11 railway projects, out of which 6 were high-speed railway projects. Mr. Sondhi will take the questions at the end of his talk. And I will request Mr. JL Singh to please put the first slide, and then I will hand over to Mr. Sondhi to take it forward. Mr. JL Singh, will you please share the screen?
Hello.
Thank you. Now, can I request Mr. Sondhi to please take it from here?
Not able to start the video.
We can hear you, Mr. Sondhi, and I think if your video is not there, then you can start talking. The screen is being shared.
Thank you very much for giving me this opportunity of talking to all of you. My presentation is based on my work in China as a consultant with the World Bank. The information contained in this presentation is based on several reports and documents issued by the World Bank. Next.
Next slide, sir.
Yes, next, please. Can you hear me?
Yeah. One. Okay.
I'm going to cover the following aspects of this presentation. How the high-speed railway network has grown and how there was a long-term vision and planning for setting up high-speed railways in China. What are the types of high-speed railways which have been constructed there and operated? Service profiles and fares which are being charged? How the unit cost of high-speed railways projects in China is much lower than the international experience. Maintenance systems, financial performance and economic viability of the high-speed railways, and what are the factors which has enabled China to be successful in setting up high-speed railways. Next, please. The railway development in China is perhaps the largest railway development project ever. China has grown its railway system from 28,700 kilometers, route kilometers in year 2000 to 120,000 route kilometers in 2020. And they plan to continue to grow this railway network to 170,000 kilometers by 2025 and to 200,000 or 2 lakh route kilometers by 2035. This extension of railway network has enabled China to meet transport demands and to provide efficient and cost-effective transport for goods. And the railway expansion has, in many ways, supported the economic development and also created employment, because all these projects, construction projects, require a lot of labor. Next. So as far as the high-speed network is concerned, the first high-speed railway was opened in 2008 to tie up with the Beijing Olympics, which were set up in August 2008. And then it has been growing steadily, and by 2021, we have 38,000 route kilometers of high-speed railway in China. So you can see that in over a period of 13 years, 38,000 kilometers of route kilometers of high-speed railway has been set up in China. I mean, as compared to India, we are trying to set up 500 kilometers of high-speed railway between Ahmedabad and Mumbai. And we'll talk about how long it takes in India as compared to how short duration it takes to set up or to construct high-speed railways in China. And the plan is to go to 70,000 route kilometers of high-speed railway by 2035. High-speed railway services provide very high capacity, much shorter travel time, comfort, convenience, and also improved regional connectivity. I'll discuss this point when we talk about the economic benefits of high-speed railways. Next, please. So how come that China has been able to develop their high-speed network so rapidly? So this is basically based on the long-term vision and planning which the Chinese government has been able to set up. China has been experiencing annual GDP growth of 10%, and since 1980, the GDP has doubled every 8 years. And between 2000 and 2018, 47% of Chinese population rose to middle class status. So this in itself is a fantastic story. The railway network had to be expanded very rapidly as the demand for rail transport was increasing, and with people having higher income, their desire to travel also was increasing rapidly. And high-speed railway network was included as an integral part of the plan to enhance the railway passenger capacity. It is expected that the increasing income substantial proportion of users shall migrate from conventional rail to HSR. At the moment, about 60% of the passenger travel is taking place in China on high-speed railways and 40% on the conventional railway. The conventional railway is up to run trains, passenger trains, up to a speed of 160 kilometers per hour. But the high-speed rails are high-speed trains are much faster. Next. Next, please. So, initial efforts were made to develop high-speed railway in China by local development of design, construction, and manufacturing processes. 2 such projects were initiated in the year 2000, but they were completed in a period of 3 or 4 years. But the problem was with they were 200 to 250 kilometer speed railways. But the problem arose with respect to reliability. There were failures, particularly on track as well as on the rolling stock. China has deployed very considerable resources to adapt international technologies. I believe more than 1,000 engineers had been working on this since middle of 1990s, and they had traveled all over the world to study and adapt the international technology with respect to high-speed railway. A special group was established for high-speed engineering technologies, and these people were told that they will always be dedicated to high-speed railway work. Unlike Indian railways, where people have been moving from normal railway working to high-speed and back, this thing was not adopted at all. People or engineers who were recruited or appointed to the high-speed railway work knew that their whole lifetime of work will be on high-speed railway only. So that gave them a long-term interest in their work. Initial focus of the China Railway was to transfer of technology for 250 kilometer high-speed railway system. But over the period of 15 years, the Chinese engineers had absorbed the international technology almost totally, and within a short period, they were able to locally upgrade the technology to 350 kilometers per hour system. You know, when the first train of 300 kilometer speed was introduced, the technology partners of China wanted to get some kind of a benefit, financial benefit for expansion of high-speed railway to 300 kilometers per hour. At that time, the China Railways told these partners that you transfer this technology for 250 kilometers per hour. Now we have upgraded the technology to 300 and 350 kilometers per hour. So there is no question of us giving you any financial benefits for the upgraded technology. Next, please. The medium and long-term railway plan was launched in 2004, and it covered a period of 16 years up to 2020. So here I want to emphasize the point that the plans which are made in China are for much longer duration of 15 to 20 years. The important aspect is that these plans could not be modified, and except that they can be enlarged, but any projects which are included in a medium and long-term plan are not allowed to be deleted or to be modified. The only thing you can do is to add to the plan. This has a very important economic aspect and an engineering aspect, because all agencies which are interested in taking part in high-speed railway work get an assurance and of the credibility of the plan, and they can then make investments with respect to the design, technologies, construction, rolling stock, products, etc. So it gives people an assurance that they have a long pipeline of business available for next 15 years, and therefore these agencies in the private sector as well as in the public sector as well as in the research area, design area, are then activated to take suitable action. Thank you. Next, please. So the first plan, which was issued in 2004, had proposed 12,000 kilometers of high-speed railway by 2020. That means over the period of 15 to 16 years. Then there was this financial crisis of 2008, and the government in China wanted to create more employment, and they increased the HSR network target from 12,000 to 16,000 kilometers. In 2016, the long-term plan has been modified again, and now it consists of 8 horizontal and 8 vertical corridors, and which will be constructed, which had a target of 30,000 kilometers by 2020 and 38,000 kilometers by 2025. In 2020, the target for high-speed railway has been raised further to 17,000 route kilometers by 2035. High-speed trains by 2035 would serve 98% of the cities with population of more than 5 lakh or 500,000 persons. Next, please. So this map, if you see, you can see the vertical lines as well as the horizontal lines. Vertical is north-south and horizontal is east-to-west. And as you can see, China is a large country, but most of its economic activity is in the eastern half of the country. So the effort in the plan is to connect all major cities with high-speed railway. Next, please. We have trunk lines designed for a maximum speed of 350 kilometers, these lines have passenger traffic only. They are dedicated passenger lines. Other main lines designed for maximum speed of 250 kilometers. These are also passenger dedicated lines. And there are some lines which have been designed for a maximum speed of 200 kilometers. And some of them are for only passenger traffic, while some others are for passenger as well as container and express freight trains, which operate at 120 kilometers per hour. So basically, there are 3 types of high-speed railway lines in China. And most of the high-speed railways are new construction, but a few are upgraded existing corridors also, particularly for these 200-kilometer secondary lines. Next, please. So, what are the secrets for great success of building high-speed railways in China so rapidly? So one of them is that the design has been standardized. Technical specifications standardized for alignment of track, subgrade, bridges, culverts, tunnels, signaling, communication, OHE, power supply, etc. For example, the horizontal curve radius for 350 kilometers is 7,000 meters. For 300 is 5,000 meters. For 250 is 3,200 meters, etc. Similarly, track is ballastless for higher speeds and ballasted for 200 kilometers. Signaling train system, control system, CTS3 and CTS3 or 2. Now, the advantage of the standardization is that the manufacturers and the designers know what is going to be utilized in the future, and they are able to concentrate as well as make investments in the production of components required for these projects. Next, please. I will now describe two typical high-speed rail corridors. The first one is Shijiazhuang to Jiangsu. This is a passenger dedicated line, 350 kilometers long. This is part of the Beijing-Guangzhou high-speed railway, which is 2,300 kilometers. It runs from Beijing to the south, north-south line. The maximum speed of this railway is 350 kilometers per hour. Axle load is 17 tons, ballastless track, slab track. Almost 300 kilometers of this railway is laid on viaduct. It is very similar to what we are doing it in Ahmedabad, Mumbai high-speed railway. Viaducts reduce land requirement, and it also permits easy access of people and animals below the track from one side to the other. Very large radius curves are used for this project. And ATP, cab signaling, radio communication, all those technology items are present. A safety system monitors weather conditions, seismic activity, and fire. Construction period, the important thing is that the construction period of this railway was 4 years. It was commissioned in December 2012 after a period of 4 years. Now, this is a very remarkable achievement. Now, when we compare it with how much time other countries take in implementing railway projects. Next, please. So you see here the standard length of a beam for viaduct is 32 meters in China. It's 800 tons in weight, and it is carried on an 18-axle beam carrier. A viaduct is shown here, and here is the slab track of this particular railway. Next, please. This is another passenger dedicated line, Guiyang to Guangzhou. This is 847 kilometers long. The maximum speed here is 250 kilometers per hour. This railway passes through a lot of mountains. Highest elevation is almost 2,000 meters. 234 kilometers of track is laid on bridges or viaducts, and 467 track is in tunnels. So more than half the track is laid in tunnels, and 28% track is on bridges or viaducts. The construction of this railway started in December 2008, and it was commissioned in December 2014. So just look at this, 847 railway in a mountainous region was constructed in 6 years. Next, please. So, as mentioned by Mr. Khare this morning, the cost of construction of high-speed railways in China is 30 to 40% lower as compared with other countries. it is about $20 million per kilometer for 350 kilometers speed, and about $17 million for 250 kilometer lines. How this lower construction cost, how has it been achieved? High quality preliminary designs are very important, and so that during construction and during the detailed design, not many changes are made. Efficient construction, then you get competitive pricing because ample capacity for construction and supply of high-speed railway products has been created. Contractors are able to amortize their cost of capital investment over several projects over 10 to 15 years. Now, as it was mentioned earlier, that this very specialized equipment is being designed and manufactured for the Indian high-speed railway project. The contractor is going to amortize the cost of those equipment in one project only, because he is not sure when these equipment will be utilized again, because India does not have a pipeline of high-speed railway projects. It has only one project which is under construction. Now, this is not the case in China. A supplier of, say, even the contractor for tunnels, he knows that he is going to be very busy for next 20 years. So he is invested in a lot of equipment for tunneling, and he is going to amortize the cost of investment over a period of 10 to 15 years and not in one project. And when long tunnels are to be constructed, they are constructed from several locations, and 10 meters of tunneling per day is a normal delivery by the tunneling contractor. The unit labor cost in China is also lower than other countries, and an important factor is that there is not so much problem in land acquisition. Next, please. The type of services which China Railway is providing is either non-stop or limited stop. No train stops at all stations. In an hour, there may be 6 trains running per hour in a section. So maybe 3 of them will be non-stop, and the other 3 will stop at selected stations, but not all stations, because that helps them to get the relatively higher average speed. High density corridors have 60 to 70 million passengers per year. And such corridors run 70 to 130 pairs of trains. And in peak hours, 8 trains per hour. 8 trains per hour means every 7 minutes or 7.5 minutes, a train leaves the station. Medium density routes 40 to 50 pairs of trains per day, at least half-hour service. Long distance services, Beijing-Shanghai is 18 kilometers, the same distance as Delhi to Mumbai or Delhi to Kolkata. The journey is covered in 4 hours, 28 minutes with 2 stops. 44 pairs of trains operate on this section of 1,318 kilometers. On a shorter section of Wuhan to Guangzhou, about 1,000 kilometers, 54 pairs of trains are operated every day. That shows that how much of demand is there for high-speed trains in China. Beijing to Tianjin is 117 kilometers. 100 pairs of trains operate on this line. The operational period of trains is from 7 a.m. till midnight. And no trains run between midnight and 7 o'clock in the morning. Average occupation of these trains is about 70%. Morning and night trains don't have so many passengers. average traffic density is of 50 million passengers per year, is twice that in Europe, but 70% of that in Japan. Average high-speed railway trip is about 500 kilometers. And HSR is popular for users between 200 to 800 kilometer distance. Next, please. Now talking about fares, there are two classes in China. The first class fare is similar to airfares. Second class fare for the slower high-speed railway is similar to bus fares. The idea is that people will travel on high-speed railways other than a bus, and the fares are much less than in Europe and Japan. I have a table here which shows that 300 to 350 kilometer speed trains in China, the first class fare is about 11 US cents, and the second class fare is about 7 US cents. And for lower speed, 200 to 250 kilometers, it is 5 cents per kilometer for first class and 4 cents for second class. Now, the China Air services is the same as the first class fare, and the second class fare is similar to that for bus services in China. Next, please. It's very important that when you have a high-speed railway or any railway, that you have a robust maintenance system. A test train is run every day in the morning to check the infrastructure at the start of operations, and an instrumented train is run every 10 days. There is a 4-hour maintenance block between midnight and 4 o'clock in the morning that permits adequate time for maintenance of infrastructure. Modern EMU maintenance depots have been set up, which work round the clock. An average train set covers about 2,000 kilometers per day and undergoes a maintenance schedule at intervals of 4,000 kilometers. That means every alternate day. And overhaul at the works of the manufacturers after 600,000 kilometers. That is about once in a year. The most important thing was that a large number of technicians were trained for the maintenance of infrastructure and rolling stock. No unskilled labor is required at all for high-speed railway maintenance. All of them are either diploma holders or graduates in engineering. Thank you. Next, please. Joint ventures are developed or set up between China Railway Corporation and local zonal railways and provincial governments. So there are two revenue models. I think we'll skip this slide. Next, please. So the financial success of a high-speed railway depends entirely on the traffic volume. At current fares, it is feasible to recover all cost elements only on high-density 300 kilometer high-speed railways. The costs are operation and maintenance, interest payment on loan taken for the project, and principal repayment. So a few of the high-speed railways, which have a traffic of, say, 50 million passengers per year, are able to recover all the three costs I have indicated. But the slower speed lines, which have a lower traffic density of 10 or 15 or 20 million passengers per year, they are able to recover only operation and maintenance cost. They are not able to make interest payments and principal repayments. they will be able to do so only when the traffic volume increases. Next, please. Economic viability is basically evaluation of cost and benefits to the society, and avoidance of external costs due to reduction in expansion of road network and airports, reduction of accidents, road congestion and greenhouse gases, improved regional connectivity benefits are there. Economic analysis of few projects have shown positive economic rate of return in China, and that is of the order of between 4 and 8%. China is an exceptional case since it has lower construction costs and relatively high traffic density as compared with other countries. So it is not certain that in all countries high-speed railways will be economically viable. The requirement for economic viability is that there should be high density of population, large cities which are about 200 kilometers apart, and which generates very high level of passenger usage of the high-speed trains. Next, please. So why has high-speed railway projects succeeded so well in China? So the first thing is activating a credible plan to set up 12,000 kilometers of HSR over 15 years, focus on absorbing international high-speed rail technologies by deploying hundreds of engineers over a period of 10 years and more. Now, this is where I think India is perhaps not doing as well as it could do. We have to absorb these technologies so that the future projects are not dependent on foreign collaborations. Competitive supply industry, which was developed because there was confidence in plan implementation of the government. Insistence on technology transfer in design and products. Several joint ventures between foreign and local companies were concluded, but the success of transfer of technology was very, very high. Project management teams are never changed during the project. You see, the projects may take 6 years or 7 years to implement. The project team and its managers remain there from the beginning till the end of the project. I have been associated with the dedicated freight corridor in India. There we have a change of the managing director and the chief engineers every 3-4 years. The result is that there is no long-term commitment by anybody to the project. Now, the project management team in China has full commitment to the delivery of the project in a timely manner and within the estimated cost. Incidentally, there is almost all the projects that I have worked with, excepting one, have been completed within the initial estimated cost. One project, there was an overrun by 5%. Now, there is a very strong financial incentive to the project managers team. This incentive can be up to 150%, 1.5 times of the basic salary of the engineers and managers working on the project team. And as I mentioned earlier, the projects are delivered very rapidly with 5 years for a 500 kilometer HSR is a very common delivery schedule. Next, please. So the achievements are the high-speed network has been implemented at a rapid pace over the past 18 years. exceptional pace of construction of HSR projects, localization of manufacture. Almost 90% of the products required for HSR are designed and manufactured and supplied locally. Quality control has been of a very high order, and the maintenance systems are very effective. Next, please. So the the future is that 50,000 kilometer of high-speed line will be constructed by 2025, and by 2035, 70,000 kilometers of high-speed line will be operational. High-speed trains would serve 98% of cities with population of more than 500,000. The rail network will grow to 200,000 kilometers by 2035, and high-speed network will be 70,000 kilometers by 2035. And there is every confidence that these targets shall be met, as has been the case in the past. Next, please. Thank you so much for your patience, and any questions you have, you're most welcome.
Thank you very much, sir. We have 20 minutes for questions. So if I, as the moderator, can take the privilege of asking the first question, sir.
Yes.
Do you think that these HSR services will be the future of the railways all over the world?
You see, high-speed railways are very useful and very popular in two aspects. One is for distances up to 200 kilometers. They help people to relocate themselves away from a large city, say Mumbai or Delhi or Kolkata. At the moment, it is very hard for people to find accommodation in these large cities, because if you find it, it's very expensive. So with a high-speed railway, you are able to live 100 or 150 kilometers away and still come to your place of work within a period of 30 minutes to 45 minutes. This is what the metro systems are doing at the moment for distances up to 40 to 50 kilometers. So therefore, high-speed railways for short distances are going to be very, very popular near large cities. Large cities, I mean, is with population of 10 million or more. Similarly, and also as the incomes grow, as the economy, the GDP of countries grow, people's incomes increase, so they are able to afford the relatively high cost of high-speed railways. So the second type of railway, which is high-speed railway, which is going to be very popular, is for distances up to 800 kilometers. That is a distance which you can cover in less than 3 hours. If 500 kilometers you can do in 2 hours. So people prefer to use such railways as compared to air services or using buses or using cars. So I have no doubt that with the increasing incomes in countries which have got high density of population and large cities, spread, say, every 200, 250 kilometers, high-speed railways are the future of railways in the foreseeable future.
Thank you, sir. And there is a question from Mr. Anand. He wanted to know what percentage of the project cost is funded through multilateral agencies.
China is a very big country. In other countries other than China, 50 to 70% of the project cost is funded by international agencies. But in China, the international agencies' contribution is always less than 10%. And basically because China has the ability to make investments on their own, but they involve the international agencies because that gives them a window to the international practices and also enables the Chinese engineers and Chinese economists to understand the methodologies used by international agencies in evaluating as well as supervising uh, uh, construction projects.
Atulya, I had one question. He says, who designed and built the rolling stock?
The initial 100 train sets were imported by China from 3 or 4 international companies which were involved in the manufacture of high-speed rolling stock. Only a small number came as fully assembled. The rest were in knockdown condition. But over a period of 2.5 years, the number of engineers who were deployed for the collaboration with these suppliers, they were able to start the manufacture progressively in China, and within 3 to 4 years, these trains were being manufactured in China, with only 20% components being imported, and that the import content has now been reduced, I think, to about 5%.
So, could you share with us the method of launching which they used? The launching of girders. How do they launch a girder from one pillar to the next? They carry it on a 18-axled bridge.
Yeah.
And then
If you go to my presentation, I have got some pictures there. If you go back to my presentation, then I'll be able to show you those devices. But essentially they are hydraulic devices which are used for lifting the beam and moving it forward, and then dropping it on the pillars. And actually this morning, Achal Khare has shown the similar equipment being used in India, because the Indian beams are actually longer. They are 40 meters and they weigh about 1100 tons, whereas the beams used in China are 32 meters and they weigh 700 to 800 tons. So essentially, it is a specialized equipment, a hydraulic system by which you lift the beam from both ends and then move it forward and then slowly drop it on the columns, on the pillars.
Next pillars. I think the ultimate comment came from Apurva, who said that should we hand over our high-speed railways building to China? So I think we'll leave it at that. If there are
No, I don't think. What we have to do is to learn from why the China experience has been so successful. The success factors I have listed. The main thing is that we have to have a credible plan. People see whatever the government says, people should believe it. And they should, because Indian Railways, for instance, keeps on issuing plans every 5 years or so for next 20 years. Those plans, nobody believes them because they are never implemented. So they are only paper plans. Whereas in China, when a government issues a plan, they implement it and everybody believes in it. So when you have credibility, then you start developing the production capacity as well as design capacity to serve those projects. So the credibility of the government and a long pipeline of projects, so that people have they know that they are in this business for 15 years or 20 years or 10 years, because nobody is interested in just one project being implemented. And I think the High-Speed Railway Corporation has had a lot of difficulty in persuading people to start manufacturing locally components required for Ahmedabad, Mumbai, because what after that, what is going to happen if somebody develops a capacity for a particular product and he supplies X numbers in the next first 2-3 years. After that, his capacity is idle because he is not sure whether next order is going to come. And it's not only one, but in China, for the same products, 3 or 4 manufacturers are there, so that they compete. There is a competition in the pricing of such components, and that lowers the cost of construction.
So there was a news item saying that China too has run into financial difficulties, and they may rethink their expansion. I don't know whether that is a fact or whether they will simply go ahead and reach 70,000 route kilometers from the existing levels, or are they likely to review?
We have been through a very serious financial crisis in 2008, and during that crisis, they increased the the scope of high-speed railway from 12,000 to 16,000. You see, the Chinese government is very, very sensitive about unemployment. So high-speed railway projects create a lot of employment. The sources of employment in China over the last 15 years has been construction of office and residential buildings. That, of course, has run into some problem now. So construction activity has been the basic strategy for generating employment in China. And I don't think it is going to be curtailed in the near future. Baki, who knows what's going to happen after 15 years? Like we have at Ukraine now, nobody foresaw this sort of thing.
So, thank you very much, sir. I think the chat box is.
I would like to, firstly, compliment that the example of China has been very, very emphatically put forth, and this will really motivate us with a vision. And basically, the low cost of construction and the economy of scale, that is huge amount of work that has kept them moving. And but I will, which was very quietly emphasized, that technology transfer and assimilation of technology will be a key for us forward for further. We have also got a high-speed rail plan for 2031, 41, and 51. So those things needs to be assimilated. But one question which I had noticed, that you have somewhere given a figure that 0.7 dollars, 7 cents per kilometer is the cost of the ticket. That makes it around 35 rupees, or let's say for this Ahmedabad Mumbai, if we calculate, so that will come around 17,500 rupees minimum ticket cost would be there. But as it was being mentioned in the first session, the ticket cost was kept for India, it was proposed around 3,000 rupees only. So there is a wide gap between these two figures. So how?
No, there is no gap. You see, the Mumbai figure is 3,000 rupees for 500 kilometers, which is 6 rupees per kilometer, whereas China is 5 rupees per kilometer.
No, it's 5.5 dollars. That is 35 rupees.
No, 7 cents.
It is cents.
7 cents.
It is 7 cents. 7 cents multiplied by 75 is less than 6 rupees. So it is, in fact, the price in India is slightly higher than that of China.
Okay,
the tariff which was suggested this morning is similar to what China is doing.
That's quite right. So definitely quite a motivating scenario for India as well.
So the important thing which I want to make is that this morning 7 projects, railway projects, high-speed projects were listed. we should say in which order they are going to be done. And then people should believe that plan. In India, our difficulty is that we do not believe in what the government tells us, because our past experience is that all these plans are all bogus plans. They are just for elections.
So the government doesn't change in China. It is just a single party government. So there is an advantage. So there is no elections. There is no change in government. So there are those issues. But anyway, thank you very much, sir. We have completed our
Most welcome.
1 hour
Most welcome.
for the allotted time for this session. And it has been extremely interesting and illuminating. And thank you so very much for your presentation, sir.
Thank you. Bye-bye.
Bye-bye.
Thank you, Mr. Virdi, and thank you, Mr. Sondhi, for this lovely session, 1 hour session, which had lots of good questions also. Do we have time for the first question on the quiz, or do we straight away go to Adrian and